Welcome to all. In this class, we're going to discuss about minerals, to be specific, soil minerals. So, what is the definition of minerals? So, mineral is a naturally occurring homogeneous element or inorganically compound that has a definite chemical composition and a characteristic geometry. Remember this word because it will be useful while we're dealing with the crystallography of minerals. So minerals having a very homogeneous element and it is a very inorganic compound. So minerals are two types. Those minerals have a more than two elements. Example, gypsum, also like a calcium sulfate. It has a two elements like calcium and sulfate and some part of water also is there. So it's a combined form of mineral. More than two elements. And olivine. Olivine also having magnesium ion and silica oxides. Two or more combined. And feldspar. There's a potassic feldspar. So these are the combined form of mineral. And another form which has only one element. Example, copper, iron, calcium, and some other non-elements. There is particular classification of minerals based on their chemical composition will be discussed later on. So these are the forms of this is the definition and what are the forms of minerals are there. So minerals, to be brief, it's a homogeneous. It's a homogeneous means a very particularly single element, sometimes very homogeneous element, or inorganic compound that has a definite chemical composition and a characteristic geometrical form. Okay, coming to the next, and how these are distributed. So in Earth crust, as we earlier we have discussed about the rocks and minerals. Please go through it. In Earth crust, minerals are how far they are distributed and what form they are distributed. So, when a molten magma solidifies, the different elements are freely arranged themselves in occurrence with attractive force and geometric form. More than 2,000 known minerals and only a few occur in abundance of earth crust. So more than 2,000 minerals were formed during this molten magma solidifies, but only very few are be abundant, just like this. This is the rare mineral. These are some anime, like imagine. These are the rare materials and a very few abundant minerals like quartz and feldspar. We will discuss all those things. Where to be simple, magma is solidified ejection during a process of ejection and they are freely arranged according to their attractive force and according to their geometric form. What is this geometric form and attractive forces we'll discuss in a crystallography lecture later on. So let us see, in this lecture we mostly focus on classification of minerals. Very first, based on mode of origin, minerals are classified into two types. One is primary minerals, another is secondary minerals. So primary minerals are nothing but they're the chief component. They're the primary minerals, they're the main original minerals. So how they are classified? According to their crystallization. So arranged in order of crystallization, how they are, or how many types are there? One is ferromagneseous. In that ferromagneseous, there are orthoclase and inosilicates. Important constituents of these orthosilicates are like iron manganese, ferromagnesis, just name itself is a ferromagnesis. Iron manganese are the chief constant. In this orthosilicates, we will discuss in a crystallography lecture regarding what is this orthosilicate, inosilicates. Example of orthosilicates are olivine, pyroxenes, and amphiboles. These are the most chief chemical constituents. Try to remember these constituents. Ferromagnesius, in the name itself, iron and magnesium. Most of them are iron and magnesium is quite common in everywhere. How far this distributed on Earth crust? Around 16.8 percentage. These are distributed. Another example are called phyllosilicates. Example of phyllosilicates are biotite and muscovite. So these are the muscovite and these are the chemical composition, important constituents other than silica and oxygen. Because tetrahedra, octahedra, there are many, the two fundamental blocks are there for crystallograph. There is a tetrahedra, octahedra. We'll discuss later on. Example, how far they are distributed? 3.6 percentage. Followed by non-ferromagneseous, quite opposite to the ferromagneseous. Example, tectosilicates. Example are feldspar. Example for the and under this tectosilicates, albinite, anthronite, on orthoclase or microline, and quartz. So quartz is distributed 11.6 and remaining combined all these three are around 61.6 percentage. So these are the classification under the primary minerals and under primary minerals these are the ferromagnesis are there, phyllosilicates are there, and non-ferromagnesis are there. These are three types are there. Under primary mineral according to their arrangement of crystallization. These three are there. Remember these names. We'll go details in further classes. And after that, secondary minerals. Secondary minerals are nothing but they are the clay minerals. There is a separate lecture will be on the secondary minerals. Example, your sodium, potassium, calcium, magnesium, iron, and aluminium, and hydroxides. These are distributed around 6%, but plays major role in soil science. We'll discuss. So this is what I'm so insisting a lot. Silicate minerals, mainly the secondary minerals. Silicate minerals occupy 90% of the mineral composition of the rocks of earth crust. So what is rocks and all? Please go through the previous lectures. The silica tetrahedron is a fundamental building block for all silicate minerals of earth crust. So remember this line, so that will be useful in a future coming classes. So again, there is another classification based on the quantity how the minerals were classified. So these are all essential minerals and accessory minerals. So based on the quantity, there are two again there are two types of classification. One is essential minerals and another is accessory minerals. What are essential minerals? So these are the chief constituents. So these minerals are chief constituents of the rock, which are regarded as the characteristic component of the rocks are known as essential minerals. I am here using a rock. What is rock? Rock is nothing but it's a combination of different essential minerals or different minerals. Please go through the previous lectures. So that is so these whoever the mineral which has a chief constant. So the main constant are called the accessory minerals. What are the examples? One is quartz, feldspar, and micas. Now let us see what is accessory minerals. So quite opposite to the essentials and to accessory. They're the small constant. They occur very small quantity whose presence or absence is of no consequence as far as characteristics of the rock is concerned. Is called accessory minerals. So they are very negligible. Whose presence or absence there is no meaning or there is no impact on that particular rock. But whereas essential minerals, name itself essential means very important. They're the chief constituents or constituents of the particular rock. Whereas essential minerals, accessory minerals, are they, their presence or absence are having no that much impact on rock. What are the examples? Tourmaline, pyrite, and magnetite. Remember this tourmaline will supply some more boron. And based on specific gravity, how the minerals were classified: light minerals and heavy minerals. What are light minerals? Minerals having specific gravity below 2.85 is considered as light minerals. So those having a specific gravity below 2.85 are considered as the light minerals. What are those? Quartz, feldspar, and muscovite. So these are the images: quartz, feldspar, and muscovite are they. So which having less than 2.85 specific gravity are considered as the light minerals. What are heavy minerals? Quite opposite. Those have above 2.85 gram cc. My apologies, here I forgot to mention unit. So 2.85 gram per cc are considered as the heavy minerals. So quite opposite, which is less than 2.85 minerals are called light minerals, and with having more than 2.85 are called the heavy minerals. Example: hematite, pyrite, limonite, ognite, and hornblende, and olivine. So these are the images: hematite, pyrite, ognite, hornblende, and olivine. So these are the examples for light minerals and heavy minerals based on the specific gravity. Now let us see what are the weatherability of the primary mineral. What is weatherability? These also there is a separate lecture on weathering of soils. We will deal there. But just we will see the listing. So in early stage of weathering, which type of minerals will be weathered? Olivine, pyroxenes, amphiboles, biotite, albite, anthronite. And in intermediate stage of weathering, which type of minerals will be released? This is called the orthoclase, muscovite, quartz. In advanced stage, no primary minerals will be observed in the advanced stage of weathering. So during early stage of weathering, we can see release of this olivine, pyroxenes, amphiboles, biotite, albite, and anthronite. Whereas in intermediate weathering, we can see orthoclase, muscovite, and quartz. In advanced stage of weathering, no primary minerals will be left to observe in an advanced stage of weathering. Okay. So that's why we can see most of the young soils contain several primary minerals, but highly weathered soils, they should not contain any type of primary minerals. So in a young soils, we can see a lot of primary minerals, whereas in highly weathered soils, we cannot see any primary minerals. So this is the last classification we can see based on the chemical composition. Based on the chemical composition, these are the list. Silicates, mostly rock forming minerals. Just remember, very important, silicate, oxides, sulfides, sulfates, halides, carbonates, and native elements. Example, copper and gold. These are the examples. So like this, these are the different type of classification we can observe in minerals. Thank you.